this calculus problem is real life. Okay? If I am producing anything, I'm looking to sell 1,000,000 jars of Sadler's pickled beets, or whatever I happen to sell. Okay? I can save myself a lot of money the smaller the least within. Okay, right? So for anyone like for Coke and Pepsi and all that stuff, they spend a lot of money trying to make sure the can, one, fits in your hand properly, and also is as small as can be with giving you the most material, right? Because they sell billions of cans out of Matron in a year. What equations will I need in this case? What are the two things that I'm going to need to solve this one? Circumference, sort of. Surface area. I'll give you the equation for surface area, and you guys are going to do it. The surface area equals 2 pi RH plus 2 pi r squared.
Is that R2 inch?
Oh my goodness gracious. Is that okay? All right, what else do I need? Someone other than Chris. What else do I need for this question? Yeah? Volume. Okay. What are we optimizing? Are we optimizing volume or are we optimizing surface area? Surface area, okay? So what equation, the thing is, if I'm looking to optimize surface area, I have 2 pi RH plus 2 pi r squared. What variable does it make sense to substitute out of there? And don't listen to Derek. Don't listen to Derek because Derek's going to give the wrong answer here. Haley, what are you whispering there? What are you whispering there? What's that? Oh, I know. That's okay. Don't be afraid. Yeah, Chris, go ahead.
Well, I was thinking because it says with a capacity of 250, isn't that volume?
Yeah, definitely. So we are going to use volume to substitute. But what variable are we going to get rid of in surface area? What variable are we going to get rid of? R or H? The R is totally incorrect. Now hold on a second. Let me rephrase. Because here's the thing. Hold on. The R will work. The R will work. But if I isolate R, just look here. If I isolate R here, it's going to equal the square root of V divided by pi H.
That sounds fun.
Right, which is going to be a mess. And also
isolate
here, isolate there.
I thought you meant like actually like factor out.
No. So what you're going to do is you guys are going to do this. I'm going to start with 250 equals pi r squared H. That's what you're given. You're going to isolate H. And then you're going to sub into the other equation and then optimize it. Okay? You guys can do that. And I think I'm going to be kind this year. I can't believe I'm going to do that. I think I am going to just give you that formula sheet for the test, so no one tries. Okay? So just the questions are going to be compounded then, okay? But I mean, like, do you remember? I don't know if you remember that sheet, but it's. I can bring it up here. Let's pause the video. I want you guys to try that. All right. Grown. All right. Let's take this one up here, guys. Here we go. So I'm going to isolate H here. H is 250 over pi r squared. When I substitute this back in, here's some argument in the back, which is okay. There's just one thing I just want to mention here, guys. Here.
Isn't the R supposed to be there? Like 2 pi r and then the bracket?
Thank you. Because this is one thing that not at least 2 or 3 people that I went around didn't look at here. What should I do right at this moment before I take before I do the derivative? Derek, go ahead.
I cancel the pi and one of the other.
Yeah, anything you can do to simplify it. You'll still get the same answer to do the derivative here, right? But this is easier to do. So this is going to turn into surface area equals 500 over r plus 2 pi r squared. And I'm also going to change that into you see what I did there? 500 r to the negative 1.
Okay.
It's probably easier to go like that.
Oh, okay. Okay. That makes sense.
Okay. So it took a little bit of algebra. You guys are in calculus. I'm confident you guys can do this though. Have confidence in yourselves. So do you like the young actually have confidence? You're gonna hate me at the basketball coach next year. Play defense. So it's no. Okay. So can I get somebody to take the derivative here? Bailey, since you're back today, can you be brave to take the derivative for me? Hopefully.
Would that be -1? Would be -500.
Yeah.
Would be -2.
Yeah.
Plus 1 pi r.
Thank you. I'm sorry I didn't make you do that. Your voice sound good. I'm sorry I made you do that. All right. Why did we only do that? Go ahead.
So we can optimize it to make S or the surface area 1 to 0.
Okay, now watch the magic of this question. If this doesn't make you happy, you don't love algebra, okay? Because watch what Mr. Sadler's about to do. Okay, ready? So 0 is going to equal -500. I'm going to call it like this. So it's going to be 500 over r squared equals 4 pi r. Okay, can somebody tell me how I'm going to solve for r? Because this is the magic step. I'm going to give it a second to think about this. Because this is cool. This is cool. Yeah, again, this is a math teacher telling me this.
I thought it was cool.
Yeah, this is very cool, okay? Chris, how do I solve for r? What do I do?
Do you just multiply it by r squared?
Yes! So this turns into 500 equals 4 pi r cubed.
That is pretty cool, Mr. Sadler.
It is cool. 125 over pi equals r cubed, and hopefully I did that right. Okay. So this is just good algebra, okay? It's a little tricky. How do I get rid of an r cubed?
Cubic root.
Cube root, okay? Or if you don't have cube root, you can do it like this. Right, you can change to 1 power 1/3 if you don't have a cube root button on your calculator.
Oh, do you want us to keep the pi?
Yes, you have to.
Oh, okay.
Yeah. I just do it all in one step there. And I got for an answer 3.41 about.
That's right.
Well, only for like word problems we should put it.
You can leave it as an exact value. If you want to call this 5 over the cube root of pi, you can leave it like that if you want to. Do you want the height? Did they ask for the height? What dimensions? I guess they did. Okay, to finish up then, we're going to say my height was equal to 250 over pi r squared, which is 250 over pi times 3.41 squared. I got 6.28. Oh, 6.82, sorry, whoops. Therefore, now this shouldn't be surprising because I think you learned this in grade 9. Okay, for when you talk about optimum shapes in grade 9. If it is a radius of 3.41, what's its diameter? 6.82. So it means the diameter should be the same as the height to optimize the shape, which shouldn't really be shocking to you, okay, because you learned that in grade 9. We're going to get to more complicated shapes in calculus. We proved that with calculus, though. Why does Coca-Cola not sell me a can that is 3.41 centimeters by 6.28? Well, it'd be the same. It'd be like for them, they want to save the money, though. Why do they make their cans like this?
To optimize surface area?
No, definitely not. Because it's definitely not going to do that. Or why is that? I'm going to embarrass Haley there. Look at her Gatorade container. Why does her Gatorade container look like that and not like this?
It's easier to hold.
So you can hold on to it. That's the only reason why, right? The optimum shape would be like, you know, you ever got a can of tomatoes and you see it, it's like this big around and flat, that's the optimum shape for a can, right? But no one can hang on to something like that, okay? Okay, let's pause this and we'll do one more and then we'll call it a day.
Oh, there's a second. You can't hang on.
Yeah, I said, I did, yeah, but.